number 13. This is an interesting problem. So we've got 40 meters per second here and 30 meters per second here if we go by the scaling of this is 40, 10, 20, 30, 40, that makes this negative 30. Let's actually go ahead and see what we can do to solve this problem. Let's get their displacement. So they're 200 meters apart. Let's just get the displacement of each train. I'm going to change colors here. I've got the strawberry train and I've got the grape train. And let's just see how they go. So the grape train, its displacement, okay, is going to be 1/2 times negative 30 times 4. So it moves negative 60. So it starts, I'll assume it starts at the 200 mark and goes backwards, goes back 60 to 140 meters. Now let's look at the strawberry train. Its displacement, delta x, is 1/2 times 40 times 5, just looking at this triangle here. That's going to be 100. Okay. So it starts from 0. Okay. And goes to 100. So the idea here is I've got this train at 200. Okay. And it goes back to 140. Sorry, let me be stricter. I've got 200 meters of track. I've got this train that starts at 200. It goes back negative 60, lands at 140. Then I've got the other train here. It starts at 0 and winds up at 100. So the separation here, sorry, this goes to 100. So the separation here is exactly 140 minus 100. The answer is 40 meters using the area. All right, last question. A police car is at rest when suddenly a speeder passes it going 40 meters per second. The police car accelerates from rest and catches up to the car at an acceleration of 4 meters per second squared. Oh my gosh. I want to say something now. I love this problem. Can I make that any clearer? Can I make this any clearer? That's all I'm going to say. So here we go. X of the car, so we got the police officer. X of the police car is 4t. So x of the police car is going to be 1/2 at squared plus v naught t plus x naught. Let's write that down. That's going to be 1/2 times 4t squared. That's for the police car. Now let's look at the speeder car. Speeder. Its speed is given by 40 times t. That's distance is rate times time. So now what we're going to do is they meet at the same place and at the same time. So what I'm going to do is I'm going to set these equal. This is kind of like the buggy question we did before. So we'll say 40 times t equals 1/2 times 4t squared. And we'll kind of solve from here. Working with this, we can divide both sides by t. So we're going to get 40 equals 1/2 times 4 times t. So 40 is 2 times t. So t is 20 seconds. That's when they meet, and you just solved part A. Now for part B, now that I've got this time, I can plug it back into here or here, either one. I'll take the easy one. 40 times t is 40 times 2, which is 80 meters. So they meet at the 80 meter mark. If you want to do it the other way, you could actually plug it into here, and you'd get the same thing. You'd also get 80. So the answer to B is 80 meters. And we have just completed the problems for your practice exam. And I'll put these online right now.